To solve a radical equation, we want to follow these 4 steps to find the values of x that will make this equation true. So to start off, we want to use inverse operations to isolate our radical. So we want to isolate the square root of 2x minus 2. So we can do that by subtracting 1 from both sides of our equation. And that is going to leave us with x minus 1 equals the square root of 2x minus 2. So that is step 1. We have now isolated our radical. Step 2 is we want to use an exponent to clear the radical. So what we can do then, because we have a square root here, we can get rid of our radical by squaring our radical of square root of 2x minus 2. Now, whatever we do to one side of our equation, we also have to do to the other. So we want to make sure we are also squaring x minus 1. When we square x minus 1, we are taking x minus 1 times x minus 1. And so when we distribute here, we want to make sure we are multiplying each term in each expression by each term in the other expression. So we want to multiply x times x, and we want to multiply x times negative 1. We want to multiply negative 1 times x. And finally, we want to multiply negative 1 times negative 1. So when we multiply this out, x times x gives us x squared. X times negative 1 gives us negative 1x. Negative 1 times x gives us negative 1x. And negative 1 times negative 1 gives us a positive 1. So when we combine like terms here, we get x squared minus 2x plus 1. So we are now going to write x minus 1 squared as x squared minus 2x plus 1. When we square the square root of 2x minus 2, that's going to leave us with 2x minus 2. So we are now done with step 2. We have cleared our radical. Step number 3 tells us to use inverse operations to isolate our variable of interest. Because we have x squared and we have negative 2x on one side of our equation, and we have 2x on the other side of our equation, we want to get all of our terms on one side of our equation so we can set it equal to 0. So to do that, we are going to subtract 2x from both sides, and we are also going to add 2 to both sides to clear out this side of the equation. So that's going to leave us with x squared minus 2x plus 1 minus 2x plus 2 on one side of our equation, and that's going to be set equal to 0. So now we want to combine our like terms here. So we have x squared, we have negative 2x and negative 2x, which will leave us with negative 4x, and we have 1 plus 2, which will leave us with a positive 3. We're going to set that equal to 0. We have now written our equation as a quadratic that is set equal to 0. So we can solve for x by finding the x values that will make this quadratic equal to 0. So to do so, we are going to factor our quadratic. So we are going to use the diamond method. So let's identify our a, b, and c values here. Our coefficient in front of our x squared term is positive 1. Our coefficient in front of x is negative 4, and our c term, our constant, is 3. So when we use the diamond method, we are trying to figure out the factors of a times c that add to equal b. So our a term times our c term is going to leave us with 3, and our b term is negative 4. So we are trying to find the factors of 3 that will add to equal negative 4. So our only factors of 3 are going to be 3 times 1 and negative 3 times negative 1. When we multiply those two sets of terms, they're both going to give us an answer of 3. Now the set of factors that will give us our b term that will add to give us negative 4 are negative 3 and negative 1. So those are the factors we are going to be working with. Because -3 times -1 multiply together to give us 3, and they add together to give us 4. Now that we have identified our factors, we can add them to x to write our quadratic here in factored form. So x squared minus 4x plus 3 is equal to x minus 3 times x minus 1. Now finally, to find the values of x that will make our equation equal to 0, we want to set each factor equal to 0 and solve for x. So this is going to leave us with x equals 3 and x equals 1. So these are our two x values that will make our equation here equal to 0. These are our two answers to this equation. But we are not done yet. The final step here is we want to substitute these x values that we have found back into our original equation to check for extraneous solutions. So let's start with x equals 3. Let's substitute 3 in for x in our original equation. So that's going to leave us with 3 equals 1 plus the square root of 2 times 3 minus 2. So when we solve, we get 1 plus the square root of 2 times 3 is 6. 6 minus 2 is 4. The square root of 4 is going to be 2. So we get 3 is equal to 3. This checks out, this is true, so we know that x equals 3 is a real solution of this radical equation. Now let's do the same thing for x equals 1. So let's substitute 1 in for x. When we do that, we get 1 equals 1 plus the square root of 2 times 1 minus 2. When we simplify, we get 1 equals 1 plus the square root of 2 minus 2, which is 0. The square root of 0 is 0, so we get 1 equals 1, which is also true. So x equals 1 is also a solution to this radical equation. So this radical equation has two solutions at x equals 3 and x equals 1. And we are done with this problem.